Chemistry and you are watching Chem Science.
In this video, I'll be solving question paper 6-2, that is alternative to practical paper of the variant 2 of IGCSE chemistry, that is 0620 chemistry of the examination series October-November 2024. But before I go ahead, let me show you that we have an IGCSE chemistry app specially designed for the students, which will give you an hands-on lots of resources for the revision and the exam preparation material. So in this app you will be able to see that there are all the topics which are there in our new syllabus, and in each and every topic you have an study material, video lecture, subjective test for the practice, MCQ test for the practice, and for study material you have notes. So notes of each and every topic of each and every chapter you will be able to see in this. For example, here we have a small example of isotopes note. Similarly, we have lots more topics in each and every chapter, plus you have a video lecture, subjective test, and so here are the list of video lectures. So again, for each and every chapter you will have such video lectures, you will have MCQ tests, you have subjective. Along with that you have revision test also. Revision test is, now you can select any number of chapters you want and you will get all the so many MCQs and subjective questions for the revision test just for those selective chapters and topics. Along with that you will also have an access to past papers and MS of minimum last 5 to 6 years. So just go ahead to the site which is given in the description of this video and download it with your small login procedure. So let's now start solving the paper. Now here is question 1 of the alternative to practical paper 6 of 0620 chemistry, again of the 2024 October-November series. So let's start with the question 1 here. Question 1 is, a teacher uses the apparatus shown in figure 1.1 to pass an electric current through the molten mercury bromide at a temperature of 300 degrees Celsius, and the apparatus shown here with all this setup. Now we can see in this apparatus setup that we have 2 electrodes labeled here. We have a power supply, we have an external circuit, we have 2 electrodes which are dipped in the mercury to bromide which is in molten form, and then there is an connecting pipe going to a boiling tube which is placed inside the beaker filled with ice, that is for the condensation. Now let's see that what are the sub questions which are following here. Now during the process shown in figure 1.1, molten mercury to bromide breaks down and forms bromine and mercury. Table 1.1 shows some information about the mercury to bromide, bromine and mercury, and they've given the melting point, boiling point and the density when the liquid is in grams per centimeter cube. Here is all information given, where we can see that the melting point of the mercury bromide is highest. Then we have mercury and then we have bromine, and then the lowest melting point is for mercury. Now draw an arrow on figure 1.1 to show where the apparatus should be heated. So let's see where the apparatus has to be heated. Yes, the apparatus has to be heated here, and you need to draw an arrow here to show that the heating has to be done at the mercury to bromide portion of the boiling tube. So here we draw an arrow, it's done. Now name the item of the apparatus labeled A. Now where is the apparatus A? Okay, apparatus A is labeled to the boiling tube. Now you can even label it as a test tube, but I'll suggest you write boiling tube because the boiling tube is a little bigger than the test tube, plus it is used for heating or cooling purpose. So here I'll suggest you write boiling tube rather than test tube. Okay, name the process shown in figure 1.1 which breaks down mercury to bromide. Now the process name is electrolysis. Electrolysis is the process with the help of which we can break down ionic compounds into its elements by the passing of electricity. Okay. The D question is the electrodes used in the process shown in figure 1.1 are made from platinum. Now give two reasons why platinum is suitable material for the electrodes. Now for any electrodes which we use, there should be two necessary things, and that is that the platinum or the electrodes which we use should be unreactive. So platinum is unreactive, that is it doesn't participate in the electrolysis along with the mercury bromide. Another thing is that whatever material we use for electrode should be the good conductor of electricity, then only it can act as an conductor. So here we write platinum is good conductor of electricity. That's one of the necessity for any material to be used as an electrode. Okay. In E, on figure 1.1, draw an X to show where mercury will be collected. Now it's written draw an X. Okay, so let's understand where the mercury has to be collected. Now if mercury and bromine are the two substances which are formed as a product in this process, then bromine at little higher temperature, as we are heating, bromine at little higher temperature, you know that the boiling point of mercury is plus 60 degrees. So if we heat, it will be above 60 degrees. So mercury will pass out as vapors through the condensation tube. But then bromine will pass through the condensation tube and will be collected in the boiling tube in A. But mercury will be collected as a liquid mercury on heating. So obviously that mercury will fall down as a liquid at the bottom of this tube itself. So you have to draw X here at the bottom of the boiling tube carrying mercury to bromide, and that will be collected as a silvery metal at the bottom of that tube. So we have drawn X there. And explain why ice is used in the experiment. Now we know that bromine at a higher temperature is a gas. It will be passing through the tube, collecting tube. So to condense bromine to liquid bromine, that's why we use the ice to condense it and to collect it as a liquid bromine. And so we are using ice to minimize the temperature. Now let's go ahead and see what is there in the question 2. Question 1 is over there. Now question 2 is a student investigates the rate of reaction between aqueous iron 3 nitrate and aqueous sodium thiosulfate. Now the student does 5 experiments using the apparatus shown in figure 2.1. So here we can see that an apparatus is set up where there is an 100 centimeter cube beaker filled with 50 centimeter cube of aqueous iron 3 nitrate, and in this solution we are adding from the top aqueous sodium thiosulfate, and here is a printed sheet below this beaker so that we can see from the top that whether the prints are visible or not. So let's see what is an experiment 1. Here experiment 1, it's written here that with the help of measuring cylinder we are adding iron 3 nitrate to the beaker, and then it's kept on the printed sheet, and then we are adding 25 centimeter cube measuring cylinder. We are using 25 centimeter cube cylinder to pour 15 centimeter cube of aqueous sodium thiosulfate. Now stir the content and look down from above the beaker. When the text on the printed sheet becomes visible, that time we are noting down with the help of a stopwatch. So the time to see the printed sheet will be recorded in seconds to the nearest whole number, and then the beaker is rinsed with distilled water and the experiment is repeated using 10 centimeter cube of aqueous sodium thiosulfate. Now in the first experiment we had used 15 centimeter cube. In second experiment we are using 10 centimeter cube, and the process remains the same. In experiment 3 we'll be repeating the same experiment with 7 centimeter cube of the thiosulfate, and so on. So if we go ahead and look at the table which is drawn here, we can fill up here that the volume of the sodium thiosulfate used in the first experiment was 15 centimeter cube, then 10 centimeter cube, and in the remaining experiments we had 7, 6 and 5, which can be added here as 7.0, 6.0 and 5.0 centimeter cube of sodium thiosulfate. So here also we'll add 1 decimal place to show the volume. Now if we note down the time shown in the stopwatch here in seconds, so here the minute hand here is on 0, so whatever time is here is in seconds only, there is no minutes. So you can see that here there are 24 seconds, just one mark less than 25, so we have 24 seconds here. Now here we can see that out of this we have 51 seconds here, so 51 seconds. Okay, in the next we can see that it's past 1 minute, 1 minute and 3 seconds. So 1 minute is 60 seconds plus 3, that is 63 seconds, and now it's written that to the nearest whole number, so we are writing it in seconds with the whole number. Okay, the next part we can see that it's 1 minute plus we can see that there are 35 and 38 seconds. So 1 minute and 38 seconds, that is 60 plus 38 seconds, that is 98 seconds. And in the next we can see that there are 58 seconds plus 60, so that is 118 seconds. So that's done, 118 seconds. That was the last column with the last row. We have filled up everything. Now we can in the next part see that there is an grid shown here. Let's see now what is the question here. Write a suitable scale on y-axis and plot the results of from the experiment 1 to 5 and figure 2.2. Draw a smooth curve of best fit. Now here is a grid. I will pause the video and I'll draw the grid, that is graph for you. Now here we can see that the grid is shown here with x-axis having the volume of sodium thiosulfate solution, and on y-axis we have time taken for text to become visible, that is a time in seconds we have to do a plot on the y-axis. So let's label it, but let's understand that what are our seconds given here. So we have our timings from 24 to 118. So if we divide all this, we'll get a scale till 120. So now you can see I have chosen a scale where I can cover right from 0 to 120 on y-axis, and I have covered almost the full grid. If you choose a different scale, you need to remember that you need to cover more than half the grid. Understand? Choose a scale which will cover more than half the grid. Your graph line should cover more than half the grid, and that only will be acceptable. So choose the scale accordingly. Now let me plot the graph for you. Now here you can see I have plotted all the points with cross. So you have to draw such cross rather than points with a sharp pencil and then dark HB pencil, which is easily visible. Now we can see that this graph this point seems to be anomalous and moving out of the curve. Here we can cover all the 4 points in a curve, but this will be out of the curve, so we have to leave it. We don't have to take that in consideration and don't include that in your line. That is the most important. I have seen most of the students making such a mistake, making a very zigzag line if you cover an anomalous point. So leave the anomalous point and draw the points, cover the points on a line which lies on the line. So let me draw the line for you now. So now you can see I have drawn a curve also in black, which is leaving the anomalous point out, and there is a smooth curve. Yes, you can draw a better curve than me, because as I have drawn a digital curve on the screen, it's not very clear and very smooth. but yes, with pencil and eraser you can draw a better curve. Now let's go ahead with this C question. State why the contents of the beaker are stirred after adding aqueous sodium thiosulfate to aqueous iron 3 nitrate. Now that's the only common reason for this is to mix all the reactants thoroughly so that it can react easily. So mix all the reactants thoroughly. We keep on shaking or we stir the mixture so that the reaction goes ahead. Now deduce which experiment has the highest rate of reaction. Now the rate is highest only when the time taken is very less, and in the first experiment itself we had seen that the time taken was the least. So experiment 1 has the highest rate as the time taken to complete the reaction or to see the text was least. Okay. E part is use your graph in figure 2.2 to predict the time taken to text to become visible if the volume of sodium thiosulfate is 12.5 centimeter cube. Now 12.5 centimeter cube is where we have to find it out from the grid. So 12.5 is, you can make out that 13 is here. That is 1, 2, 3, 4, 5, 13 is here. So 12.5 is halfway between it is here. So here now you have to draw a line with the scale and extend it to the graph. Now here I am not using the scale, but you have to use, and if I extend it to the curve which I have drawn, obviously I get another extension line towards the y-axis, which will give me an answer of 38 seconds here. You can see that it is 1 square below 40 and 1 square is equivalent to 2 seconds. So here I have an answer for 38 seconds, and so let me write it as 38 and seconds also. The unit has to be mentioned very clearly, that is necessary here. So 3 marks is for your answer from the grid, 1 mark for the unit, and the 3rd mark is to show that extended lines on the x-axis and y-axis towards the curve, which I have drawn, and you also need to show it to get the 3rd mark. Okay, so if we go ahead with the F part here, explain why it would be an improvement to measure the volume of aqueous 3 nitrate in a burette rather than measuring cylinder. And the simple reason is that burette is more accurate in measuring the volume of any liquid compared to the measuring cylinder. So we write burette is more accurate. You can write it in a full sentence as I spoke also. Explain why it is not possible to use a volumetric pipette to measure the volume of aqueous sodium thiosulfate used in the experiments. Now you know that the volumetric pipettes have fixed volumes of say 5, 10, 20, 25, but here we needed a variable volume of 6 centimeter cube, 7 centimeter cube, 5 centimeter cube. So as we can write that pipette has fixed volume to measure, but we need to measure variable volume. So we can't use pipette. We can still use burette, but we can't use a pipette because pipette has fixed volumes. Okay, the 3rd part is describe how the reliability of the results in this investigation can be checked. Now reliability is that we can repeat the experiments, and compare the readings or compare our results, compare the results to find out whether the results or the time which we had calculated or seen earlier, noted down earlier, was correct or reliable or not. So that's how we can check the reliability of our results. Next G part is describe how the results of the experiments would change if the experiment was repeated using a narrow and a taller beaker. Explain your answer. Now if we are looking through from the top of a beaker, if the beaker becomes very longer, then it takes a longer time to see through it and make the text visible. So change in the result will be the time taken will be longer, or time taken will be more than the earlier experiment. And the explanation we can write is that the depth of the solution or the beaker is more, or you can say depth of the beaker is also more. Any one you can write here. Okay, describe additional measurements that must be taken to determine whether the reaction in this investigation is exothermic or endothermic. Now if we want to find out whether the reaction is exothermic or endothermic, obviously the additional measurement should be the temperature with the help of thermometer. So again here our question 2 also ends, and let's see what is question 3 lying here for us. So here is question 3, which is an qualitative analysis. A student tests two substances, solid M and solid N. Okay, the test on solid M is shown here. It's do a flame test on solid M, and its observation is lilac flame. Now there are the table given for the qualitative analysis in the last pages of this paper. You can see here at the bottom the lilac flame. Let's see where is the lilac flame given here. Okay, here is the cation anion test given, the flame color also given, and you can see that the lilac color flame is given for the potassium ion. So let's see our question ahead. Okay, we can see that solid M contains potassium ion. Okay, dissolve the rest of the solid M in water to form solution M and divide it into 4 portions. The first portion is add 1 centimeter cube of nitric acid and silver nitrate, and we get cream precipitates. Now again, if you compare it with the cation anion test, you will see that with silver nitrate, if it gives cream precipitates, we have bromide ions. Okay, to the second portion solution M, add aqueous sodium hydroxide dropwise and then in excess, and here is a green precipitates which remains in excess NaOH. That shows that it doesn't dissolve. It does not dissolve with green precipitate. That shows that it has Fe2+, that is ferrous ions. That also you can compare in the cation anion test. Okay, chalo, let's see that what is there in the cation anion test. Yes, we can see that with nitric acid and silver nitrate, bromide ions gives cream precipitates, that we have already noted down. Yes, with sodium hydroxide, the green precipitates, if it's soluble, then it is chromium ion, but if it's insoluble, then we have Fe2+ ion, and that's why we have concluded that it is Fe2+, because the precipitates are insoluble. Okay, to the third portion we are adding 1 centimeter of NaOH, a small aluminium foil, warm the mixture, and it turns a damp red litmus paper. Litmus paper remains red only, so litmus paper does not change. If there is no change in the litmus paper, that shows that the nitrate ions are not present. Now for the test 5, it says that we are adding nitric acid and barium nitrate and it gives white precipitates. Now that is a positive test for sulfate ion. So that shows that the sulfate ion is also present. The question A is explain why a yellow Bunsen burner flame is not suitable for a flame test. Now that is because the yellow flame is not giving proper heat. So you can in other words also write that the yellow flame is not hot enough, or we can say that it doesn't give enough heat. So anything is acceptable with the similar meaning. And in the identify the 4 ions in solid M, that's the next question, and we have already identified that one of our ion was potassium ion, then we had bromide ion, then we had also Fe2 plus ion as mentioned here, and then the sulfate ion. So the remaining 2 ions are ferrous ion, that is Fe2 ions, and then the 4th ion is sulfate ion, that is SO4 minus. So these are the 4 ions present in solid M. Now the next is the test on solid N is given here, and the solid N is ammonium carbonate. So we have an ammonium ion, that is NH4 plus, and the carbonate ion, that is CO3 minus. Now these are the 2 ions present in solid N. Record the expected observations. Now the C is the student transfers approximately half of the solid N in boiling tube and adds about 10 centimeter cube of sulfuric acid to the boiling tube. Any gas produced is tested. Now if we are adding any acid to the carbonate here, it's going to produce salt, carbon dioxide and water. Now what's the salt produced here? The salt produced will be ammonium sulfate. So the salt is ammonium sulfate, and the gas produced is carbon dioxide gas. So observation will be the fizzing or effervescence will be seen, and if we test the carbon dioxide gas, we can see in the gas test table that gas will turn lime water cloudy, That's the test of carbon dioxide. So that will be given because carbon dioxide gas is produced as one of the product. Now the student dissolves the remaining solid N in water to form solution N. Now we are dissolving again the solid N in water, and the solution N is divided into 2 portions. So to the first portion of solution N, the student adds 2 centimeter cube of aqueous sodium hydroxide and gently warms the mixture, and any gas produced is tested. Now we can see that if the ammonium ion is present in our test, cation anion test, then on heating it's going to produce ammonia gas. Now if ammonia gas is produced, the common test for ammonia gas is that it turns red litmus paper blue. So the observation is that the gas produced turns red litmus blue. That's the observation produced for the gas produced. Okay, to the second portion we are adding aqueous ammonia. If aqueous ammonia is added to the ammonium ions, there should be no change because it doesn't give any precipitates. Again, you can check that in the cation anion test that the ammonium ion does not produce any test. So we can say that no observation or no reaction we can write here. Okay, so here our question 3 ends, and let's see what is there in the last question. Here it says limes and lemons are citrus fruits which contain citric acid in their juice. Now citric acid reacts with the alkalis such as sodium hydroxide. Now sodium hydroxide reacts with the acids which are present in the limes and lemons. Okay, plan and investigate to find out which of lime juice or the lemon juice contains the most concentrated citric acid, and that is the only acid present that we have to assume in the limes and lemons. Okay, your plan must include the method to use and how the results are used to determine which juice contains most concentrated acid. Now you are provided with lime juice, lemon juice, sodium hydroxide and the apparatus and the chemicals. So if we are testing which one is more concentrated, and the hint is given here that it reacts with the sodium hydroxide, then the obvious experiment which we can do to find out the concentration is a titration. Now, if we are doing titration, we need burette pipette, so that are the apparatus will mention here. Along with that, we'll need an indicator also. Now the best acid base indicator which we can use here for is that methyl orange, the most commonly used indicator. So we'll mention the names of all these apparatus and the method and the indicator, so that we need to get 6 marks description here. It carries 6 marks description, so we need to mention all the names, and as such it's written in the question here. So starting with what, we will perform titration of lime and lemon juice with sodium hydroxide using methyl orange as indicator, So we are giving the name of the method which we will use to find out the concentration. Now if we are finding out the most concentration, then the solution, which is lime or lemon, should use more sodium hydroxide to neutralize and to show the change color if it is more concentrated. So that's how we are going to conclude. So if we describe the method, the first thing is we need to keep in mind that what are the things we're going to keep same. What are the factors which we'll keep same? So the first thing is that the volume of both the juices should be kept same to make the test fair. So the things to be kept same is the volume. Now what we going to measure is the volume of NaOH required, volume of sodium hydroxide required to neutralize or to show the color change, and that is what we are going to measure. So we can say that we will take a fixed volume of lime juice. You can mention any juice first. So fixed volume of lime juice, say 25 centimeter cube, with the help of pipette. So we are mentioning here the apparatus which we are using. So with the help of pipette, you can also mention it volumetric pipette in a conical flask. So we are transferring 25 centimeter cube of the lime juice with the help of pipette into a conical flask. The next step will be add few drops of methyl orange indicator. Add few drops of methyl orange indicator. That is to see the color change and to find out when is the lime juice getting neutralized. Now add aqueous NaOH from the burette till it shows color change, and note down the volume of NaOH required. That's how we are going to note down. That's the most important part here. Now we can repeat the experiment. With the same volume of lemon juice this time, same volume of lemon juice, and with the same concentration of NaOH. So we are going to use the same NaOH which we had used in our earlier experiment, same concentration of aqueous NaOH. Note down the volume of aqueous NaOH required for color change, of the methyl orange, required for the color change. Now this is the experiment which we have performed, but at the end we have to conclude also. And how are we going to conclude is that the juice which required greater volume of aqueous NaOH is more concentrated. That's we need to mention here, that how are we going to find out that which juice is more concentrated. So we need to specify here that the one which required greater volume of NaOH will be more concentrated. Now what is the common mistake which I have seen here is the specificity of the phrases used. So here we need to mention that we are using the volume. At times I have seen people using same amount. Now amount is not the proper phrase to mention the volume. So volume of lime juice, volume of NaOH to be mentioned, not the amount. So this is how you're going to describe the whole experiment for the 6 marks, and this is each and every step which we have described here, whichever is asked in the question, because it's written method used to be explained and also how the results are used to determine that which juice is more concentrated. So again, in the last step we have mentioned that how are we going to conclude from it. So here also our last question 6 ends here.